Okay, so let's start over. These are the 2-4 notes on solving multi-step inequalities. We do jump from one step with multiplication division to multi-step because many of the rules for solving equations apply to solving inequalities. Except when multiplying or dividing by a negative number, the inequality symbol must be flipped. And we use this little symbol here. I use it to remind myself to flip the inequality, but I also use it for feedback to you to make sure you remember to flip the inequality. And just in case you need a reminder on steps to solve equations, which also work for solving inequalities, we're always simplifying first. Simplifying could include distributing or combining like terms. Then we'd want to undo addition or subtraction, which also includes positive and negative constants, numbers without variables. And then step 3, we always want to undo the multiplication or division as the last step. And that could include, this is where we would most likely flip our inequality symbol. So whatever number is in front of the variable, the coefficient, we would multiply or divide to eliminate that number and isolate the variable. Okay, but we just need to remember that we have to flip the inequality symbol whenever you multiply or divide by a negative number. All right, let's look at number 1. So the first step, we want to, nothing needs to be simplified, but we do need to undo the addition subtraction. So right now that 5, which is a constant, and it's positive, so we're going to subtract 5 from both sides to isolate the x term. So we have negative 9 times x is greater than negative 18. Then we'd want to undo the multiplication. So right now we're multiplying by negative 9. So we want to divide by negative 9. And it's that step there that requires us to flip the inequality symbol because we divided both sides by a negative number. So we flip it to less than, and negative 18 divided by negative 9 is positive 2. Fill out your number line. Remember, you want at least 3 numbers. And we want to make sure it's increasing, meaning going from the smallest value to the largest value. When we go to graph, 2 is not included, so it's going to be a non-filled in circle at 2. And we're going to shade to the left because it's all values less than 2. So 2, again, we have that constant of 11. So we want to subtract it from both sides because it's positive. We're then left with y divided by 2 is greater than or equal to negative 6. Right now we're dividing the variable by 2, so then we'd want to multiply both sides by 2. So we get y is greater than or equal to negative 12. No need to flip the inequality symbol because we didn't multiply or divide both sides by a negative number. I noticed on some of your homework assignments that we have a little trouble with writing a number line when the values are negative. So remember, going less negative, that's increasing. So you want to make sure the numbers here would be negative 13, negative 12, negative 11. Negative 12, that value is included in the possible solution set because y can equal negative 12. So we want it a filled in circle. And we want to shade to the right, all values greater than or equal to negative 12. And you can always check. You can check your number line and you can check your graph. So how to check is you would look at a number that's shaded and ask yourself, is negative 11 greater than or equal to negative 12? It is, so we shaded correctly, we did our number line correctly, and we graphed it correctly. So for number 3, first we need to simplify, and we need to distribute negative 10 times 8 plus x. So when we do that, we get negative 80 minus 10x is less than negative 130. Okay, so now we have negative 80 on the left side, the side with the variable. So in order to undo that, we have to add it to both sides. So we're left with negative 10 times x is less than negative 50. Now we need to undo the multiplication, so we need to divide both sides by negative 10. And that step there that requires us to flip the inequality symbol. So we get x is greater than positive 5. So it would be open at 5 because 5 is not included in the possible solutions, and it's greater than, so we're shading to the right. Don't forget, if your variable is on the left, you can use the inequality symbol like an arrow to show you which direction to shade. Number 4, we need to simplify first. We need to combine like terms. 6x plus 6x is 12x. So we have 12 times x is greater than or equal to negative 12. We need to undo the multiplication, so we need to divide both sides by 12. And we get x is greater than or equal to negative 1. Make sure your number line is increasing. X can be equal to negative 1, so it's going to be a filled-in circle at negative 1. And it's all values greater than, so we shade to the right. For number 5, we also need to combine like terms, and we have to do so on both sides. We might as well do this all in one step. 4 plus 3 is 7, and 8 minus 1 is 7. So the next step would be to undo the addition on the side of the variable. So right now we're adding 7, so we'd want to subtract 7 from both sides. Negative 3x is less than 0. And now we're not done solving until the variable is isolated. So we still need to go through and divide by negative 3. We divided by a negative, so we need to flip the inequality symbol. So now x is isolated, and we have x is greater than 0. So you really need to go through and make sure you've finished solving and you have the variable completely isolated before you're considered done with that inequality. Set up your number line. 0 is not part of the solution set because it's not equal to, so it's going to be an open circle that's not filled in. All values greater than, so we shade to the right. So now let's work on a few word problems. We want to first write an inequality that represents the situation, and then we'll move forward by solving the inequality and interpreting if needed. The area of a rectangle is greater than 60 square feet. So just a reminder how we find the area of a rectangle. You multiply the two dimensions, length times width. Doesn't matter which is which because one property of multiplication is that the order doesn't matter. So we are multiplying these two dimensions here, 12 times 2x minus 3. That represents the area, and the area is greater than 60. So there's the inequality that represents the situation, and then we solve. So first we would distribute 12 times 2x minus 3. Next, we would undo the subtraction by adding 36 to both sides. So 24 times x is greater than 96. And the last step would be to divide both sides by 24. So we get x is greater than 4. So there's no real interpretation needed because we were just trying to find the possible values of x. So x can be anything greater than 4. In order for the area to be greater than 60 square feet. Okay, suppose it costs $5 to enter a carnival. So that's a one-time fee, admission fee. After that, each ride costs $1.25. If you have $20 to spend at the carnival, we want to find the greatest number of rides you can go on. So with any kind of inequality problem where you're spending money, this rule always applies. So the amount you spend has to be less than or equal to what you have. Okay, so any kind of spending, most likely it's going to be less than or equal to, because you can spend less than what you have, or you can spend all of what you have. So let's set up a verbal model to help us set this inequality up. So either way, we're paying that entrance fee. That's a one-time purchase. We then need to pay for each ride. So we're adding the cost of each ride. We would multiply this times the number of rides we go on. And that needs to be less than or equal to our total amount. So we know the entrance fee, we know the cost per ride, we know our total, we just don't know the number of rides. So that's what X represents. And for those of you that are having a little difficulty setting up inequalities for word problems, I strongly recommend that you attempt to write a verbal model and then replace the words with the values that you know in the given situation. So the entrance fee costs $5. We are paying $1.25 per ride. We don't know the number of rides. This has to be less than or equal to the $20 that we have. So there's our inequality. And now we need to solve. So first we'll subtract 5 from both sides. Now we're multiplying x times $1.25. So we'll divide by $1.25. 15 divided by 125 is 12. So our solution is x has to be less than or equal to 12, which means at most you can go on 12 rides. Okay, so you can go on 12 rides or anything less than 12 rides. So that's it for 2-4 day 1, solving multi-step inequalities. We will have 2 more days on 2-4 after our quiz. We tried to break it up a little bit. Right now it's just either distribute or simplify and then solve. and then we'll move forward after the quiz.